All right, so we're going to start 9.2 today. If you haven't already taken a moment to do the bell work, please hit pause and try the bell work on your own. All right, so hopefully you took that moment to try this on your own. Number one, we want to classify each of the triangles, and we want to remember that scalene means that they only have one side. Isosceles means they have two sides in common. Equilateral means three. I can also do this by angle because since I have 30, 60, 90, they're all different angles, meaning it's scalene. 45, 45, 90 means it's isosceles. 4, 7, 10, all different, scalene. 7, 7, 7, that means I have not only three sides congruent, but two, so it's an equilateral and isosceles triangle. 2, we want to find the value for x, so I'm just going to put the information that I know in. So since this side and this side are the same, it means the angles across from them are the same, so that means not only is this angle 70, but this angle 70, so I can put 70, and that also means that this is 70 by the vertical angle theorem. Now again, I see that I have sides that are the same length because this guy is the same as this guy. That means this one's across, that's 70. So across from here, this is 70. So to find out x, I would go 180 equals 70 plus x, which means 180 equals x plus 140. Subtract 140 from both sides, and I get 40 equals x. Okay. 3, I'm told that ABC is an isosceles triangle. I'm told AB is 2x plus 3. And then I'm told AC is 5x minus 2. Since this is the same as this, I can say that this is also 2x plus 3. And they told me that the total perimeter is 40. Okay, so when I'm looking at this means I can set up the equation where I can go 2x plus 3 plus 2x plus 3 plus 5x minus 2 equals 40 and solve. So I can simplify by adding my x's together to get 9x, add my other numbers to get plus 4 equals 40, subtract the 4, 9x equals 36, divide by 9, and I'm left with x equals 4. I'm told in 4 that MNP is an isosceles, and I want to find the area of MNP. So I want to find the value of x. Now, if this is an isosceles triangle, it means I have two sides that are the same, meaning this is congruent with this. So I can say that 2x minus 2 equals 3x minus 8, and I can solve for x. So I can subtract 2x from both sides, leaving me with negative 2 equals x minus 8. Add the 8. Sorry, I'm out of room, so I'm going to go over here, but x equals 6. This means I can find the height just by plugging it in, which is just 6. So I get the height of 6. The base is from here to here, which is 3x minus 2. So this is 3 times 6 minus 2, which is 16. So then for the area, I go base, which is 16, times the height, which is 6, divided by 2, which when I do that, it simplifies to be 48. All right, and then last one, we have a 12-foot ladder leans against the side of a house. The bottom of the ladder is 8 feet from the side of the house, and we want to figure out how high is the top of the ladder from the ground. So we want to use a Pythagorean theorem. Remember, this guy over here, 12, is C. So I'm going to say the missing side's B, and I know A. So I have 8 squared, not equals, plus B squared equals 12 squared. And to solve, I can subtract 8 squared from both sides, leaving me with B squared equals 12 squared minus 8 squared, and taking the square root. When I do that, I get 4 root 5, which when we simplify this, we get 8.94, which when rounded just stays at 8.9. So this is 8.9 feet long. Okay, once you get that done, let's go ahead and go to the next page. Now, this is a big page of definitions. All we're talking about today is different theorems when it comes to congruency of two triangles. Now remember, whenever we talk about a theorem, it is a theory that has been proven over and over and over again. So we can see, first of all, just as a reminder, congruent triangles are when two triangles are exactly the same shape and size. We want to remember that corresponding parts of congruent triangles are congruent, meaning C is congruent to F, A to D, B to E, and same with sides, AC to DF, and so on and so on. All right? Now, why is this important? It's because if we have specific parts of triangles, we can prove that they are congruent. So, for example, if we know that all three sides of a triangle match on two different triangles, this means that they are congruent. So side, side, side is one of our congruency theorems. Next one is what we call side, angle, side. Now, order matters. The angle has to be perfectly between the two sides. So we see we have side, angle, side, angle, side. Thus, that means that the two triangles are congruent. Next, we have angle, side, angle. Again, order matters, so it has to be angle, side in between, and then angle, which we can see we've got right here when we look at the order of those guys. So we know that one's good. Okay. And then last couple we got here, we have angles, angle, side. This means that I have two angles, and then the side is after. And again, order matters, so we have to make sure that that's the correct order it's in when we claim that it's that theorem. Do that. And then last one is what we call hypotenuse leg. Now remember, the hypotenuse is the line that is across from the 90-degree angle in a right triangle. So we see that these two are congruent. A leg is one of the other sides. So this means in a right triangle, we just need two sides. Now, if we have two legs, meaning if I just have this guy and this guy are congruent to these ones, then it doesn't work. One of them does have to be the hypotenuse. So that's what the HL stands for. Okay? So now, as we go to this next page, if we want to name the sides of angle C, so we can see that angle C is this guy right here. The sides would be CA and CB. Now, angle C would be included for those two sides because we can see that there is the C in both of them, so it's included. So now we want to name the included angle for BAAC. We see both of them have the letter A, so that's what's included. All right, and we want to know, is angle A included for the sides BC and CA? No, but C would be, right? We can see that they both have C. Now, what do we think this includes side for angles A and B? So if we look for angles A and B, it's this one and this one. So the side would be this side right here, which we would just call side AB. What is the included side for the angles B and C? Again, the same thing. We have BC. This side would be right here. So we'd say that is BC. Side AC is the included side for what two angles, meaning that what two angles are in there, and that would be A and C. Now, we want to remember that congruent triangles, they are the same size and they are the same shape. So make sure those are the two things that we remember. If you ever see this, CPCTC, this is saying corresponding parts of congruent triangles are congruent. Basically, it's taking this whole sentence and writing it so you can just write it as 5 letters. Okay? So, based on that, let's practice what the different theorems would look like. So, if I have a side, 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 that means this side matches this side, this bottom side matches this bottom side. Side, angle, side means I could pick this side to match this one, this angle to match this angle, then this side to match this side. Now there's obviously a lot of different options, so if you want to pick a different option, that's fine. Just make sure that the angle is in between. Angle, side, angle would mean if we did this angle is congruent to this angle, this side's congruent to this side, and then this angle's congruent to this angle. That would be an angle, side, angle. Angle, angle, side means that we'd have angle matches this angle matches this guy, then this side matches this side. So that's what it means by non-included side. It means the side's not between the angles, where when we have included side or included angle, that means the side and the angle are in between the other objects. Last one, hypotenuse leg. That means that this line across from the 90-degree angle has to match, and then one other leg has to match. So we'll say this is congruent to this. Now, two things that will never, ever, ever work. There is no such thing as angle, angle, angle. We can see that these triangles, they have the same angle measures, but their sides are completely different, and that's totally normal. So never trust angle, angle, angle. The other one is angle, side, angle. If you have a hard time remembering this, remember that donkeys are a pain in the butt. You can see the word that this would spell if we put it in acronym. So we want to make sure that we don't want to deal with anything that's going to be a pain, and so we don't use this one. All right, and if you have any questions specifically on why that doesn't work, let me know, and I can show you on some programs in class to show you why that doesn't work. All right. As we go to this next page, a definition that we want to go over, we're going to use it quite a bit today, and especially we're going to use it a lot next time, is called the reflexive property. Now, this is saying an angle, a line segment, or a shape is always congruent to itself, okay? So, for example, if we look at this shape that's over here on this right-hand side, we see that both of these triangles share the line AC. Well, we can say that AC is congruent to itself AC, okay? So that's what that is saying, and we're going to need that, like I said, quite a bit today, but mostly we're going to need it again on next class, all right? So what I want you to do is on your own, I want to see if you can remember the 5 congruency theorems without going to the previous page. So take a minute and see if you can remember those. Okay, so hopefully you took a moment to pause and look at those. If we go through those together, we should have gotten side, side, side. Side, angle, side, angle, side, angle, 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 side, and then hypotenuse leg. All right, so let's use those theorems to see if we can determine if these are congruent. So if I look at number 1, I see that I've got angle, side, angle, and it matches over here with angle, side, angle, which is one of my theorems. So I say yes, angle, side, angle. Looking at this one, I see that I have this side with this side, this side, this side, and then last sides together, so that means we get side, side, side. Next one, I see that I have angles match that angle, this angle matches this one, and then sides, so that is angle, angle, side. 4, I can see that they give me 3 angles, so this angle to this one to this one, and this last one to this last one right here. Remember, angle, angle, angle does not work, so no, this is not congruent, it doesn't work. Okay? 5, we can see immediately that it is a 90-degree angle. When it's a 90-degree angle, remember we only need 2 things, the hypotenuse and one of the other sides, which we can see we have. We have this hypotenuse and then one other side, so we can say hypotenuse leg. Trying number 6, we see I have this side, this angle to this angle, and this side to this side, meaning I do have side, angle, side. Okay. 7, looking at this guy, I've got this angle right here to this angle, this side to this side, then this side to this side. Angle, side, side, remember the acronym it spells, it's a pain in the butt, so it doesn't work. So no, we do not like this one. When I look at this guy, I see I actually only have 2 pieces of data. I've only got this angle to this angle and this side to this side. It's not enough information, so no, we don't know if they're congruent. Okay, this is when I was talking about that reflexive property up on top. This is when it matters. Now, we know that this angle matches this guy. Then we've got this side in between where they match right here. So we got angle, side, and then we have this angle matching this angle. So we have an angle, side, angle. Should have written that in pen. Okay. 10, remember if this is a right angle over here, this means that this also has to be a right angle. So we have two right triangles next to each other. I have a hypotenuse right here and right here that match. And by the reflexive property, this line matches itself. So that means that yes, they are congruent, and they're congruent by the hypotenuse leg theorem. Looking at 11, I can see this side matches this side. This one matches this one. And by the reflexive property, this line matches onto itself. So this would be side, side, side. Looking at 12, please, just because we've moved on from past units doesn't mean we want to forget these concepts. Remember that this angle is congruent to this angle. I'm going to do double lines. Okay, now why is that important? Because I know that this side is congruent to this side. So I know I have congruent sides. I have an angle, and then I have another angle right here. So I said this backwards because it's side, angle, angle, but we want to think of it as angle, angle, side. Honestly, both of them are the same thing, just the order matters. So make sure you just focus it on one way. So we'll go angle, angle, side. Okay, so go ahead and go to the next page and see if you can try those on your own. So hit pause and try those top 6 questions on your own. Okay, so looking at number 13, if we look at this one is trying to trick you. Side right here and this side right here match. However, all of a sudden the angle changes sides. So these are not congruent because the angle's not in the right spot. Because this triangle on the left is technically a side-side angle, and the one on the right is a side angle side. So no, these are not congruent. 14, we see that these vertical angles are together, so we've got side, angle, side. 15, by the reflexive property, we see that this line is congruent to itself, so we can say that we've got side, angle, side. 16, again, we know that these are congruent to each other, so this means we have angle, side, angle. We're going to pick as angle, side, angle. Okay, 17, we see that these are both going to be right angles because they are vertical angles. I then have a hypotenuse and a leg, so we can say that this is hypotenuse leg theorem. All right, and then last one, we see that these are both 90-degree angles, again, by they're vertical angles. Now, I don't know if the hypotenuse matches. However, I do have that this angle matches this one, this angle matches this one, and this side matches this side. So we could call this an angle, angle, side. Okay? So just because it's a right triangle does not mean you have to use hypotenuse leg theorem. Okay, so as we move on to 19 through 22, we are curious. If I want to prove that this guy, for example, with number 19, is an angle, side, angle congruency theorem, then I want to figure out what's the missing information that I need. So, for example, I see that angle M is congruent to angle S. I see that ML is congruent to ST. So the only other thing I need an angle, and remember, order matters, so I have to know that angle L is congruent to angle T. So that's what I need. If I knew that to be true, then that means that MLK is congruent to STU. All right, same thing with number 20. So if I'm looking at this one, I know by vertical angles that this guy matches that guy, so I don't have to worry about that. I know that I've got an angle and a side, and I want side, angle, side. So that means that I need this other side on the other side to match, so my angle's in the middle. So I would say that I have to know that VM is congruent to WV. I just wrote that backwards. Sorry. It should have been VW, like that. Now, if that is true, that means that the triangle VMK would be congruent to VWU. Okay? So I want you to try 21 and 22 on your own for just a minute and see if you can get that figured out. Okay, so hopefully you took a moment to look at that and see if you could get it figured out. If I'm looking at 21 and it's asking me what I need for side, remember by the reflexive property, I know QS is congruent to itself, so I just need the last side. So I want to know if QD is congruent to SR. Now, if that were true, that means that QSD is congruent to SQR. And last one, 22, if I'm looking for angle, side, you could have picked two options, okay? One option you could have picked is you could have picked this side over here. You could have said, I have to know that WY is congruent to QS. Or you could have also picked this other side over here. You could have said, I have to know that YX is congruent to QR. Either way, once I know this, that means that my triangle XWY is congruent to RSQ. So remember, order does matter, but when we're talking about an outside, it can be on either side. Okay, and those are our triangle congruence theorems, so go ahead and start your homework quiz on your own, and if you have any questions, feel free to reach out and let me know. Have a great day.